So hello everyone, I'm Gillian. I'm Systems and Networks Engineer, as you saw. I do implementations of single sign-on on IBM Mise, and I install all the products that we have. And so I'll get you through Strict today. And so to start with Strict, we had to answer some questions about how we want to approach this. And so we faced several challenges on IBM I and in general that I will go through. So the first thing is security on IBM Ise. So as you all know, IBM Ise were developed in the 90s. So there were not many networks, not many hackers or ransomware. There were pretty much nothing really security related in that time. And they are based on that, on those principles. But as the internet grows, IBM Ise went to be at the center of a lot of companies. And so often they have like accounting, business management, stock productions, etc. And so we need to secure them, and we need to have reliable security on them. And we saw that CMs and security software in general often overlook them and not really know how to communicate and how to gather information from them. So that was a big concern for us as we use the IBM I every day. The second big challenge that we had is the traceability in itself. So, well, I won't tell you what traceability is, but basically it's at the heart of new standards. So I've listed two here with RGPD, so NIS2 and DORA. There are European new standards, but the same things are coming to pretty much everywhere. So we need to have traceability on those machines as well as all the others to maintain good security and to be up to standards, to new standards. I'm going to make people enter. Sorry. So we collaborated with a lawyer, Maître Cathy Rosalie-Joly, who told us a bit more about those kind of new standards and new regulations. And so, well, I won't read everything here, but just the big thing is that we need good security. We need to have some means to check what happened to every system if there is a problem. So first of all, we need to have CMs in companies. That's normal. Maybe SOCs as well, if you don't want to check by yourself, or if you don't know really how to check and how to implement security. SOCs are a great idea. They come often with both. So SOCs often have CMs. So yeah, we can base on that. The other thing, on another key element, is that without traceability, we cannot have governance on our IT, the entire governance. We don't know what happened. If there is a problem, we cannot analyze what's happening on the systems and if there is a breach somewhere. Detection can become harder without traceability. Response and recovery can be tricky. It's a big part of those type of standards, even with our GPD, as you may already know. The last thing is that if there is a problem and it's a big one, you have to tell your, you have to notify the regulators. And without good traceability, you cannot really tell them what happened and really notify everyone that has to be notified. And in that case, the penalty can be really, really big. I'm talking about, well, millions of dollars, millions of euros, a percentage of your annual turnover. Well, it can be a huge amount, right? So we need to have those mechanisms in place to be able to provide this kind of information, right? Another thing that we saw is that service accounts on the system are often, well, not really created correctly. So we did several audits of IBM Ise, and we saw that a lot of times service accounts have really poor security. Sometimes they have their passwords noted somewhere on the system in clear text. And because these accounts access a lot of IBM applications, a lot of data, we need to be able to secure them correctly. And we saw another times we saw that they had special privileges like all object or SECOFR. So we need to be able to know what are those accounts doing, what they're doing, why, which profile, where is their passwords, etc. We need to know everything about them and what they do in daily basis. If they are automated, we have to know whenever they do something, right? And only traceability can do that. So on the IBMI, we have good tools for traceability already. The IBMI talks a lot about what's happening on the system. If you already went into the audit journals, you know what I'm talking about. It can produce a massive amount of data, but the big thing is that it's pretty hard to go in there and just check what's happening. The files are, well, not really easy to read or access in general. So because it's pretty hard to use them efficiently, it's rarely kept. And so we often see that those files or those journal files are just removed from the system. We don't keep it, and then this information is gone, right? We don't really know anything anymore. So because of all this, we created so strict, as I mentioned earlier. And so we wanted to create a tool that will provide traceability in a pretty easy manner for you to be using them and maybe send them to your SOC, for example, or to CMs.
Hello?
So let me go through it. Oops.
Yes.
Hello?
كلمتني أنا شفت يا سيدي نجوم.
Excuse me? I'm sorry. Okay. I'm gonna go for it. So how does it work? So basically, we start by acquiring all those data that I mentioned, so audit journals or exit points, for example. We acquire them and we put them through what we call the expert system. That's basically an automation tool that will check for each and every event that happened on the IBMI and give it a risk level based on how we think it's dangerous for your network or your system. And all of this is turning inside the IBMI directly. And from there, because we know that it can take a lot of space and it's not really easy to read, we send them to what we call a dispatcher. So it's basically on a VM. It can be Windows or Linux or an appliance. And from this VM, we start to store. We store them, sorry, in the local repository. So we use PostgreSQL for that, and we can access all this data with a graphical interface. So I will show you that in the demonstration. And from there, if you'd like to send them to your SOC, for example, or create an alert, we can pretty much do it. You can send it to a CM. We worked with several CMs to be able to send this data to them, parse them, and then create alerts directly in your SOC or in your CM. So we can pretty much send the data wherever it's useful, right? If you have multiple IBMIs and you'd like to centralize everything in one go, we can do it as well. Because the dispatcher is separated from the IBMI, we can pretty much send all the data from each IBMIs to one dispatcher, and from there, send it to wherever it's useful. So yeah, basically, we wanted to create a system that will work for pretty much any kind of company, and that will provide a good amount of information, first informations, traceability informations, to be able to start knowing what's happening on the system and maybe start an investigation if something is happening. And because everything is separated and it's kind of independent, between them, we can pretty much customize what we want and where we want to send all this data, and then send it to a CM, for example. So we tested Curadar, Sentinel, Splunk, Elasticsearch, and some other, I think. And then, well, just trigger an alert or send you an email if you like. We can pretty much, yeah. And if your team is not an IBM expert, if you have a security team that don't really know how to go through with the IBM, because we have a graphical software to check this data, to see this data, it's kind of easier for any engineer to just go in there and know what's happening on the system, basically. So what we can gather, so this is not an exhaustive list, it's just a big picture, but we can check for password errors on the system. We can check for, let's say, SSO connections if you have single sign-on on your IBMIs. If you don't, we can provide. If you have, we can check for object deletion and creation. We can go through rights adoptions, for example. We can pretty much check everything on the system. We can provide as well a quick audit of the system. We like to tell you, for example, if some profiles have all objects right, or if the system values that you have are well configured. We like to let you know all of these. We can check for the ADS. If you don't know what the ADS is, it's an application on the IBMI that can check for intrusions on the IBMI. It's great. It's really, really great, but it makes a lot of false positives. And so we have managed to create a way to manage those false positives. In Strict, we can check for some exit points. We have an integration with Azure Security. So if you know precisely, we created an integration with them to use their exit points in Strict. So that way they are not on what separating each other. We can work with them. And we have a database traceability probe that we can use to check what happened to a database regardless of its origin. So let's say you have a PostgreSQL database and you modify it directly through the 50-50 console, then we can know what happened on the database and from who and when. And that's a great part of this. If we go a bit further, so I mentioned that this expert system, we assessed a risk level to each and every event that happens on the IBMI. First off, we can select which type of events we want to see. For example, you're not obligated to just check everything. You can just check for some probes if you'd like, and if you don't care about deleted object, for example, then you can just deactivate it. And so this expert system, we created this because we wanted to provide a quick way to know if something was a threat or maybe something that you should consider a threat on the system. So we created for that a honeypot. Basically on the internet, we have an IBMI that's plugged directly to the internet with a public IP address. And we let it be attacked, basically. And from there, we try to analyze patterns of attackers and in which way they try to attack our IBMI, and that way we can enhance the expert system and detect patterns that could be happening on your systems if we saw something like this, and alert you directly, of course. So yeah, this expert system, well, this IBMI that I mentioned, this honeypot, is attacked around 100,000 times a day. So we have a lot of information to work with. I will show you that in a bit. And yeah, so it provides us with a lot of information how to secure and how they try to attack everything. And we have some good practices as well that we can see. And so the best way to show you is basically to show you. So I will connect to my machine and I will show you directly how it works there. Let's first go into strict directly. So all the configuration and all the management of strict is done graphically with the web server that we provide on the VM. And so we connect with an IBM I account on the IBM Identity target. So for example, this one, up, let's connect. And from there, we can manage everything that strict does. Sorry, I didn't reload. Up, that's normal. My certificate expired. Great. Check. Yeah, that's my fault there. Okay. So from there, we can configure pretty much everything that we want to activate or deactivate, or maybe if we want to manage false positives. Everything is done graphically. So you don't need to be an expert in IBM to know exactly, well, what you want to configure. And so if we go into probes here, the language, I'm going to change the language. Just up. It depends on the IBM and the parameters. Hopla. Okay, let's go into probes. So which probes I want to configure, it's done basically with a click here. We can select, for example, if we want to check for authority failures, for deleted objects. Pretty much every probe that we manage, we can just activate or deactivate here. And so the configuration is really simple. We wanted to make it as simple as possible for even not powers users to use it. And so each probe describes one thing that the IBM checks regularly. Even without strict, it will check them, but we try to access this data in a simple manner. And so from here, if we want to configure, let's say, for example, I mentioned false positives, and I mentioned the IDS that creates a lot of false positives. We could go just in a submenu here. Let's load a new exception. So we will load a new list of what's happening actually on the system, and from there we can go around and check for what could be false positives. So let's say that so those are attacks that are happening on our honeypot. So I hope that you will never have that many attacks on your systems. That could be a problem. But let's say that this IP address I know. It's not the case, but let's pretend. I know this IP address, it's in my network, and I want it to disappear from those lists. I don't want it to be an alert in my systems. So let's say that this is a server on my network that scans. So we could just select this IP address, hit here, and it will be in a list of exceptions that won't trigger anything if this IP address ever comes across again. If you want it to be a bit more precise, let's say that you have a server that does port scanning on your network, but you don't want, you just want to remove the port scanning. You don't want to remove anything else. You could, let's say, up this port. Just check this combo of IP address and ports because you port scan the well, let's say 22 port or anything. You can just refine what is the filter that you want to use to be able to remove all the false positives that are of interest for you, and let happen everything else that could be a threat, right? You can really go a bit more into details about which type of combos that you'd like. This column right here is directly sent by the probe. So this is not us that's creating the type of attack that the IDS sees. It's the IDS directly who tells us this could be an attack, this could be a scan, this could be REST prods. I don't know everything about the IDS. But yeah, and once this list is done, you can manage the list. And let's say that this is the good list that you wanted, then validate. If you don't want, I don't want to validate this, so I will return here. So managing exceptions is really simple. Managing the probes in general is really simple. And if you wanted to configure where this data is going to be sent, then as well, pretty easy. You just need to tell him wherever you want to send it. So for example, if we wanted to send it to Sentinel, we just add a new target, tell him it's Sentinel, use an API key, for example, and a means to connect, and done. If it was QRadar, for example, just tell him we use syslog for QRadar. So tell him which IP, which port, which type of syslog that you want to use, it is if it's CDF or so, and done. Right, and from there, because we didn't want to overload your CMs, because we know that we pay for the storage in CMs, we created a system that will, a threshold system that will say that if we see a threat that's upwards 80, for example, our threat level is between 1 and 99. So if it's 80 or more, then it will be sent to a CM. If it's lower, then you maybe don't really care, or maybe you don't want it to be appearing in your CMs. So we don't want to send it directly. So, and you can choose this threshold, at which threshold it will be sent. If you want to send everything, then you put the threshold low and just send it everywhere. So yeah, so it's really easy to configure. We can directly interact with the IBMI with this interface. So let's say you want to restart strict on the IBMI, you can do it directly from this web server right there. And yeah, and so it's really meant to be used by any administrator, even a Windows administrator like myself can use this and not be lost directly, practically. Once that you've sent this data and that it's stored in the local repository, as I mentioned, you can go and see the repository and what's happening. And so that's where we go to the Grafana server. And that's the most interesting part in my sense. So this is data from our honeypot. You won't ever, I hope, because there is no sound, my headphones just disconnected. So I hope that you will never have that much data in your IBMI, in your strict. But this is our honeypot. So we are attacked a lot, as you can see, 4 million times, just for password violations attempts. And so here we can see all the data that we gathered from the IBMI and start to maybe check what's happening, maybe investigate something. And so let's go a bit more into details. All the probes tell us something different, right? So we wanted to provide some interfaces that would be useful to just at a glance know what's happening. For example, the most used profiles in password violations attempts. So as you can see, it's root, admin, user, Ubuntu. Those are the type of profiles that if we see them in your IBMI, we alert you directly. It's really, really not a good idea to have those type of profiles in here. Even some that are, pretty much normal to see, for example, Oracle or uname-a. We saw that the IBMI is often treated as a Linux server when it's attacked. So if you see those kind of patterns and you see that it was blocked somewhere, that means that someone didn't know it was an IBMI, tried to attack a Linux server, and just went through and didn't access it. But if you have those kind of passwords, know that it will be attacked 100% of the times. Other type of information that we can gather, for example, that are interesting. We don't activate this by default on clients' systems because we can get the password. But it's interesting for us to enhance the expert system. Those are the FTP attacks that we receive on our IBMI, and we can gather the probe gives us the password and the account name that they use to try to access it. And so anonymous is by far the most used in FTP attacks. If you have an anonymous account on your FTP, it will be attacked 100% of the times with the password, the default password anonymous @ or anonymous alone, this is attacked a lot, a really lot. So if you have this type of accounts, remove them. And so that's just a quick way to introduce strict, right? We can really go into details about what's happening on the system. Let's say, for example, this event right here, it's a password violation attempt, PW, and we flag everything at 99 on our system. But let's say that we want to check exactly what the IBM sent us. So this is what the probe created, all the data that the probe created. And so we have some information. It's in French. I'm sorry, that depends on the IBM's language right there. But we can see, for example, that this IP address right there tried to attack our system, tried to brute force the password. He tried to use root as a username, and I'm sure he did a lot of other attacks. And so we can go from there and check for this IP address, check from where it's from, check what he did if he did other things on the system, if he tried to access other things. We can really go into details about what's happening on the system. Before this meeting, I selected an IP address that did quite some things this morning. So I will show you that and what we can gather in strict. So let's search by IP address and paste this IP address right there. This IP address this morning tried to attack us around 1,500 times. He tried to do 1,200 password violations. He triggered the IDS, so the IM probe, 140 times. He did 9 socket connections and triggered what we call QHST, so it's jobs on the system that we monitor. If we go there, we can see all the users that he tried to use to connect to our system this morning, so the column username. And yeah, so I think it's a botting attack. Of course, it's a dictionary attack, but we can see really which accounts are used the most. So of course, root users, user, NVIDIA. I saw Nexus, MySQL, GNS3, if you have this tool. Well, you can really go really in low-level data about what's happening in your system. And we store this data on the VM, so you don't really need this data anymore on your IBM. You can still remove them if it takes a lot of space. We have a dedicated database meant to be populated with this information. And we can really, if something happens on your system, you can provide the right information, who tried to connect, the IP address. This IP address specifically is from Netherlands, right there. So we can go and have this information. You can provide this information to your customers, to your users, or to the regulamenteurs. I don't think it's the right word, yeah. But you can provide this information and you can start to investigate what happens in your IBMIs. And it's not only Linux and Windows anymore. You can start with the IBMI. And the IBMI is really secure, right? This IBMI on the internet hasn't been breached. We check regularly if it has been, of course. But we saw some things in clients' companies that the IBMI saw first, and then the security tools either didn't pick up or just saw it but too late, right? We had a customer that had everything, Sentinel, Microsoft, everything. And neither the Windows, neither the antivirus, anything, saw that there was an ongoing attack. The only system that saw it was the IBMI, was the IDS, because the attackers were doing port scanning at a low level on the network. Only the IBMI saw it, and without any way to check data, they wouldn't know it, and they would be breached today. Fortunately, they could remove, well, they could stop the systems before it was an emergency. So, but it still was an ongoing attack, and it still was the IBMI that triggered the alert and not any security tool. So yeah, so we think it's a great system and a great tool to just secure your network, be in a front line and not just in a corner and never use. And we can have a lot of good information about what's happening on the systems. And so, yeah, and so just for you to know, we didn't select Grafana without something in mind. And Grafana has a great tool that we can use in its kit, and it's the Explore here. This Explore function can just query the database that we plugged in directly from the Grafana interface. So I selected a quick query here. And so from the Grafana server, you can go and query your database. And so if something is missing from your dashboard, so if you don't have the right dashboard for specifically what you wanted, you can still query it. And here, for example, as I mentioned at the start of this meeting, is the database probe that we use to know exactly what's happening to every database that we monitor regarding of where it started. And so from here, you can see all the modifications of the database that we selected. Those, fortunately, are our users. Those are my colleagues. But we can see exactly who did what and when to every database that we monitor. And so if someone, for example, changes the IBAN of a client, or someone changes the credit card information of something, then you can know exactly what happened and when. So yeah, so that's another great thing that we can just gather and start monitoring and include in our processes, in security processes, right? I see that there is a question. Oh no, okay. So yeah, so that's basically all I've had to show for strict. So if you have any questions, again, feel free to go and ask in the chat. I will make my best to read every question if you have. So yeah, so basically, we like to joke about strict as it being a CM, but not the security CM, but strict for IBMI event manager. We wanted to provide good traceability in systems, in IBMIs. We were sad, actually, that this system was overlooked by all those great security tools. And we know that the IBMI is a great operating system, is a great machine, even for security, right? Not just good for ERPs and stuff. We know that it's great for pretty much everything. So we wanted to include it in your security tools and your network, basically, your security network. And so if this tool doesn't suffice and you want to provide more surface for your data, then you can still send it to CMs and use your centralized CM to do security with the IBMI this time and not without. And yeah, that's pretty much everything I have to say. So yeah, thank you very much for your attention. If you have any questions, again, feel free to ask in the chat. I hope that I was clear enough for you guys. Thank you, David.
Any questions, anybody? Any comments?
Yeah, it seems not. It seems not. Again, this. Oh, thank you, Dennis. Great. So again, this presentation will be uploaded on our website. You have the link right here. And again, if you have any questions in the future, there is our emails, so feel free to contact us. We have the support as well, support@getit that you can contact. And yeah, and if you liked for us to communicate further, just feel free to contact. Yeah. Thank you very much again, everyone. Have a great day.
Thank you very much.
Thank you. Bye-bye.
Bye-bye. Thank you.
Thank you.